All right. Good morning, everybody, to this Tuesday where we are wrapping up our discussion on limits. As always, can I just get confirmation that everyone can both see and hear me? And we'll get started. Okay, so I need to open some stuff here. So we have something to write on that would be important. It's a little slow today. Come on, you can do it. It's coming. Eventually. Okay, where are we? Okay, so we talked about the limit as x approaches 0, for example, with the square root function, that it does not exist due to a technicality in the definition of this limit and what it means. That when I have a function that sort of has an end point in its graph, it's not defined for a whole bunch of x values, a whole section. If I'm right at the end of that, then I can't explore the behavior from both sides. So this reason is because the that's an x square root function is not defined, I'll just say around x equal to 0, technically an interval containing x equal to 0. It doesn't matter how small, I need to be going around the function and explore its behavior. But the limit as we approach 0 from the right only exists, and we're all good. Because then we are saying, no, we don't care about exploring behavior where there is no behavior to explore. It's silly. Let's just come at it where we can, and then there is nice, stable, predictable behavior, and no problem at all. So we have a two-sided limit, and we have a one-sided limit where appropriate. Okay. Now I want to look at, what do I want to look at? Let me just see what the problems I want to do before I make an example that is exactly the same as those problems. Let's do, let's do this problem now. Make a new page for the problems. Okay, just 1 second. My phone is ringing for some reason. Why now? Hold on, I'll be right back. Okay, I want to look at problem 2.3, number 3. Problem 2.3, number 3. And we have the limit as x approaches 5 from the left, square root 5 minus x. Now, oh, that's an ugly x. Getting a lot of lag because of D2L. So annoying. I appreciate that some of you responded saying what platform you prefer, and no one said that they wanted D2L, but people still complain when I don't do it. So there's a lot of things happening here. Let's just carefully talk through this so we don't miss anything. Okay. So first of all, I see a square root function, which means in general I need to be careful. That's really my only basic function in my library that has this feature of having only half a graph, so to speak. So I need to watch out if I'm at that endpoint. Now I don't need to graph it, though we will at the end to visualize what's happening. What I need to make sure, again, I can look at the form of this limit to help me. Because all the form is doing is it's looking at pieces making up the function, but separate from each other. So I see a square root piece, and I see the inside of the square root. I can separate those two if it's too confusing to me. It doesn't have to be a numerator and denominator. The only thing the form is doing is asking how do pieces behave separately. Those pieces can technically be anything, sometimes more convenient than others, to be fair. So I'm leaving the square root as a piece, so to speak. And the 5 minus x, I then have to explore. What is that doing? Because that's not a hard thing to figure out. Well, if x is getting closer to 5, I know that 5 minus x is getting closer to 0. But how exactly? Because I have a one-sided limit. 5 is always, sorry, x is always a little less than 5. A little less, 4.99, something like that, which I then subtract from 5. So 5 minus x is going to go to 0, but will it be positive or will it always be negative? That is my question. Now, you can take many approaches here. You can just reason it, talk it through. You can plug in numbers, convince yourself. You can do whatever you want to do. But I have to know, is 5 minus x always positive or always negative? What would you say? This is where you say stuff. Assuming anyone can still hear me. Could be talking to myself. That's always a chance. Positive. Because I'm subtracting something slightly smaller than 5 from 5, I'm always positive. Okay. So now there are multiple things happening here. So I'm going to write it like this. So 0 plus means that I'm, how should I say it? Let's say here, I'm okay to move forward since we have a positive number inside the square root, right? So we can at least evaluate behavior. If we had a negative number inside the square root, there's no y value to even speak of. Okay, so I need to check that the behavior I'm checking, the x values that I'm investigating, getting closer to 5, always a little less, so 4.9, 4.99, and so on, creates a number inside the square root that I can actually work with. So it has to be positive. And it is. Okay, so that's good. However, looking at this square root, in its basic form, I have the square root of something extremely close to 0. Now I need to watch out for this situation. I can't come at it from both sides. But luckily I'm not. I'm always positive, which means I'm exactly the something. It's not x, it's whatever's inside the square root. I am letting that inside something approach 0, but always positive, so I can always evaluate the square root. So I am all okay, and it's going to be 0 and existing. Now, I totally understand that this is confusing. The square root, we limit our technicalities to really only the square root, to be honest, because we're not taking a sort of a formal, proper approach to limits. That's very difficult, actually. We're taking a more informal, hand-wavy behavior approach, and because of that, the technicalities are difficult to handle. So it's really only this one that I need to watch out for in general. We have the alternative option to say, well, I can do a basic transformation on this guy. It's not so hard, right? Though, to be fair, maybe I do need to be a little careful. Let's do it up here. If I want to have the transformation approach to this, then perhaps I should put the negative in front and see the inside properly. Negative x plus 5. Then I'll take the negative out and see what kind of shift horizontally it really is. Okay, so that'll help me perhaps. Looking at it in its current form, maybe not the clearest sequence of transformations. I need to shuffle things around a little bit. That's okay. Now I see. Oh, there is a. Did we do the reflection? Yeah, right, right. When we looked at the other functions. There is a horizontal reflection of the square root. So now it sits on the other side of the y-axis. And then I'm shifting it to the right by 5. So it's going to sit over here somewhere, right? At 5. And now I see, looking at this graph, look at this behavior of x, because x is the horizontal axis. If that is coming towards 5 from the left, the y value that is suggested is in fact 0. So there are two sort of separate approaches, I would say. I don't want to mix these two. Either you can graph it and visualize it by way of some transformations. If it's not too hard, we could do that for sure. Or you have to look at the form and let that tell me how the pieces are behaving individually, and then I combine them later. It's a more difficult, I would say this is more difficult because I'm not as used to the form looking at other pieces. So, I don't know, see what you like, see if either one makes sense. We're not getting too complicated with these. The square root is the the technicality we're mainly focusing on that you'll maybe see in a test. So it makes it manageable in that I have only one or two things to really watch out for. Okay, so hopefully that helps a little bit. But it never sits that well with me, which is a downside to the informal approach that we're taking. But one con for a lot of pros, more manageable is definitely the upside. I'll take it. I'll take it. All right. So now let us look at the other sort of special case. And there are only these two. I want to remember the absolute value function. Now, let me just start by saying this is not something that I include in my basic function library because we'll see in a second why. What is the graph? Let's start with the graph. That's maybe the thing you remember the most. What is the graph of the absolute value function? Do you remember? Maybe someone remembers. I know we don't have a lot of people here, but among the 7 of you, oh no, 10 of you, no, it's only 7. I was optimistic. Maybe one of you can remember what is the graph. What do you think of when you think about the graph of the absolute value function? It looks like a V. That one's usually what people remember. Great. Okay. Oops. There we go. It looks like a V with a sharp point here because it's really made up of two graphs. This guy is y equal x, and this guy is y equals negative x. The function is really a piecewise defined function, trying to trick me, making it look as if it's one thing. It's really not. It's two pieces. It behaves like x if x is 0 or positive. Then the absolute value does nothing. But the absolute value changes the sign of the inside, making it positive if that inside is negative. So what we're really getting is two pieces attached at 0, giving me this function. It's not really one function. For different x values, they're different functions. It's a piecewise defined function. Okay, so now if I look at the limit, x approaches 0 from the right only. Now I can say, well, as far as this behavior question is concerned, there is no negative x value. I will never consider negative x values, so the left side of this graph doesn't exist for me in this question. So the behavior of the absolute value function is the same as the behavior of x, because that half of x values are the only ones existing for me in this question. So I can simplify it to the behavior of the appropriate piece in the piecewise list. Well, that's super simple. It's 0, which totally makes sense. If I travel along the graph here closer to x equal to 0, I'm heading to that bottom point, right? So that's 1. And then I can say this a similar thing for the limit as x approaches 0 from the left of the absolute value function. Well, now I'm only interested in the left side. And as far as I'm concerned in this question, the function behaves the same as its appropriate piece. When x is negative, it behaves like negative x. So I replace it. Make it simpler. The function is not the same, but for the behavior I'm looking at, it's the same. And now I'm traveling along the left side towards 0. Obviously, I'm going to 0. So that exists. That exists. And from either side, there's perfectly stable and predictable behavior. I can then, that was supposed to be a bracket. My best attempt. I can now summarize this. And because the behavior is stable, is predictable, limit exists, and it is the same, because these one-sided limits exist and are equal. That means I'm coming, I'm regardless of which side I'm coming at x equal to 0, the y value is doing the same thing. We can say the limit as x approaches 0, two-sided limit of this function is 0 and exists. So in the case of a function, and I'm picking this simplest one, absolute value is the simplest one. I don't care much for these examples, but if you look at the textbook problems, you might see some piecewise defined functions. We handle them like this. If I have a function that seems to have different pieces, or I'm not sure what's happening on either side of my x value, I can always go to the one-sided limits and say, let's just look at it from one side and then from the other. If that behavior agrees, yes, I'm doubling up my work. but at least I'll be confident in my answer. If the behavior agrees, then we can say the two-sided limit exists as well. If the behavior doesn't agree, well, then the two-sided limit question again kind of doesn't make sense. It can't exist. It has to be around the x value, the consistent predictable behavior. So let's see a simple example where I won't be able to make this two-sided limit conclusion. I think I'm out of space here. Whoops. There we go. Let's make a new page. Let's make a new page here. Okay, so let's make a small adjustment to this example. And I want to look at this question. X is coming to go approaching 0, and I'm going to take this function. Okay. So really, whenever a general rule of thumb is, if I see an absolute value function, you need to break it up into the piecewise function that it actually is. It is trying to trick me. It is not a function like the others. It comes in pieces. Well, now this only depends on the absolute value of x. So I know that if x is 0 or more, then the absolute value does nothing. It's equal to x, right? It's up here. Nope, not there. Where was it? Where is that? Oh, here it is. Haha, nice. Absolute value can be replaced with just x if x is 0 or positive. So then I'll have x over x, which means it simplifies to 1. If I have negative x values for any reason, then the absolute value of x becomes negative x over x, negative 1. So what does this function look like? Let's see it. It's often a function that's used to illustrate little examples. Now, I can't actually have 0, right? Because I would have 0 over 0. That's not 1. So I have to actually exclude the possibility of x equaling 0. But that's okay. So it's 1 for positive x. Let's put 1 over there. So I'll make an open circle, and then it's always the same. So I have a horizontal line like that. And let's say negative 1's over here. I'll make an open circle because I'm never at x equal to 0. Woohoo, that's not going to be easy to draw. Looks a little slanted. It's horizontal at negative 1. Okay, so that's my graph. Nice to visualize. So now I can look, and I see, okay, stuff's happening at 0. I'm not sure. I see an absolute value. Let's just uh, potentially make more work for ourselves, but be safe and look at either side separately. It's just gonna uh, be better in the long run. I'll feel more confident in my answer. I'm not sure what's happening. I can always separate the sides. So then I see, okay, to the right of 0, I am in this top case, which means the function behaves like the constant function 1. So that's of course just 1. There's no x's in there to even change the 1. So it exists and everything's good, which makes total sense looking at the graph, because as I come towards x from the right, as I come towards 0 in x values from the right, my y value is perfectly constant, perfectly stable, and I'm always at 1. I'm not even heading towards 1. I'm at 1. There's no uh, variation in the y values at all. So great. It's as stable as it can be. Remember, I'm not at 0. I'm heading towards 0 behavior. If I now look at what happens on the left side, the function for negative x values behaves like -1, the constant function. People don't see numbers as functions, and they really should. It's a constant function. And that doesn't change as x does whatever I say, so -1, which makes total sense looking at the graph. As I come towards x equal to 0 from the left only, the y value is perfectly stable at -1, doesn't even change. So of course then it's heading to -1. It exists, everything's good. Another interpretation of the limit, the right-sided limit, for example, if I am traveling towards 0 from the right, I am asking, can I contain the y value in as small a window as I'd like by just getting closer and closer to 0? Absolutely I can. It doesn't even change. So you're at 1 regardless. For the left side, can I contain the y value of the function to a number? I don't care what the number is, just a number that as I get closer to the x value in question, I'm coming towards 0 from the left, that y value is contained in as small a window as I want as I just get closer. Absolutely. It's as small a window as you want around -1. It doesn't even fluctuate. It doesn't change. But the two-sided limit is asking the same question. The two-sided limit is asking, can I contain my y values closely around a number by just honing in on the x value around the x value of 0. So I am making my window, I want to make my x window smaller and smaller around 0. And as I do that, is my y value getting closer and closer to a specific number? Only one number. That is the question. And if it does, then the behavior is stable, limit exists, and so on. However, what would that number be in this case? Can it be 1? Well, it's certainly from the right. I'm loving the y value of 1. But regardless of how small this x window is, I'm always going to get y values of -1. And I can make it super tiny. I'll always, for the left side of that window, have y values -1. I cannot get close to both 1 and -1. It needs to pick one, and it always is split between them. And it can't be any other y value either. And that's illustrated by the fact that these two do not agree. Not equal. Even though they both exist, there is stable behavior from either side. The behavior is not the same. It's pointing in different numbers. So for that reason, the two-sided limit does not exist because I get behavior from either side and they don't agree with each other. They need to agree with each other in order to exist. So the two-sided limit not existing can happen for different reasons. And only really by exploring these exact, it doesn't tell me the reason. It could be because the graph is perfectly stable, but different things are happening. In the piecewise function, they're not linking up. They're not agreeing with each other. I can make other random examples and just say, here's a function. Uh, let's just look at the graph and say it's a whole bunch of pieces. Let's suppose here's a piece, and then it maybe jumps over here, and then maybe it's a straight line, like that. Let's call this -1 and 2. Sometimes they even do this. Let's say that's 1, That's 2. I really don't care. Let's suppose we have a function, and for some reason it's defined in pieces. There's like a polynomial piece on the left, and then between -1 and 2, there's another polynomial piece, and then there's a straight line piece, and so on. Doesn't even matter what it is exactly. There's my graph. Let's make it even. Let's not do this. Let's do this. I'm just trying to think of all the different things here. Let's do that. There we go. Okay. First of all, now we can ask some questions. I mean, a function like this is very much made up just to illustrate the point. It's not. Uh, I'm not a fan of these ones because they're so artificial and just made up in pieces, just to illustrate what we're really asking with the limit. So it doesn't really represent anything. It's just made up of pieces. If I ask, what is the limit? Whoops. Yeah, I don't love these, but they do illustrate the point I'm trying to make. What is the limit of the function as x approaches -1? What would you say is the limit based on what we just discussed? Anyone want to guess? Any guesses for what that limit is? Of course, I put you on the spot. We just discussed it for 5 minutes and now you have to know everything? Totally unreasonable. It's all about how the pieces. So I look at the x value in question and it's a connection between the two pieces. It's right there. And if I come at it from the left, it wants to go to negative to 1 for the y value. If I come at it from the right, it's going to y equal to 2. They don't agree, so it does not exist. For the same reason as this function. I can't hone in on a y value, regardless of how small my x window is. The one-sided limits do not agree. It doesn't exist. Okay. What about the limit as x approaches 2 of the function? Let's make it easy for you. Let's do this. Let's do this. What is the limit as x approaches 2, would you say? Come on, that's an easier one. Try. Make a guess. -1. Of course, -1. Does my answer change if I do that? Meaning it's not defined at 2. There is no y value for some reason. I'm just artificially making this function. Does my limit question's answer change? Yes or no? Yes or no? Make a guess. It does not change because we've said throughout for limit, for behavior questions, we are only getting close to the x value. We will never be at the x value. So what happens there is completely irrelevant. It's behavior. As I'm traveling along this graph, what is it suggesting? It's suggesting I go to the y value of -1. As I'm traveling along this graph, what is it suggesting? It's suggesting the y value of -1. I'll never get there to find out if that's true or not. It's what is the behavior suggesting. Sometimes you see in a test or somewhere that they then manually go and define another y value at that x value. Does that change the behavior question? Yes or no? Does that change the answer to my limit? It does not, because I will never care about what is happening at that x value. Look at the graph. Let me erase these arrows. I'm saying this now so that if it happens in a test, and it has in the past, people are tricky. They make these questions just to check your understanding of what a limit is trying to ask. So I want you to be prepared. If I travel along the graph from the right, what y value is it suggesting I go to? It's -1. If I travel along the graph towards x equal to 2, I'll never get there. I'm just traveling towards it. Then I pause and ask the function, which y value are you going to? -1. -1 is still the right answer. I will never get there to find out what it actually is. It's only a behavior question. It's not find the y value question. The limit is not the same as find the y value of the function. It's completely different. Sure, if there's nothing strange happening, the function's continuous, it's one piece, everything's good, then the questions overlap. But this function is not continuous. I draw it, I lift my pen, I make a dot, I draw it again. I've made a jump. It's not continuous. The questions are now completely different. Okay. Things like that really test my understanding of what the limit question is saying and what it's not saying, and how do I figure out which one it is. Very, very nicely. That said, of course, you don't have to understand everything right away, but that is your goal ultimately, to understand just what the language is asking. I'll do a couple of problems. I'm not saying they're super hard, but they're problems. To fill the time, I'm going to do let's see, I don't even have absolute value questions in here. That's terrible. Oh, all right then. The textbook, I'm sure, has some. Let's see, I want to do number 5. Let's just do number 5 and be done with it, instead of me jumping around. Have we not? Oh, maybe we've done 5. I don't remember. We'll do it now. It is the limit x approaches 2 from the left of 5 over x minus 2. So now I need to start making a plan here. I need to know that when I see something like this, what am I going to do? I can't on the spot say like, oh, sometimes I do this, sometimes I do that. If I feel like this, I'll do that. I don't know really. I'll just see how it goes. No, it's a recipe for disaster. You need to have a plan. What do I do to understand this limit? What do I do? Starts with an F. The thing we've done all the time to help us understand behavior. The form of the limit. It doesn't get enough attention. It's so good. Now, I'm not saying it's a foolproof strategy, that it's always going to give me the answer immediately. No, it depends. But it's a good starting point because it allows me to not look at the function in its entirety, just look at the pieces. And maybe that sheds some light on what's happening here. Maybe not. At least I'll know. So the numerator stays constant at 5. Great. That's always nice. The numerator is changing. X minus 2 is certainly getting close to 0 as x gets closer to 2. But x gets closer to 2 in a specific way. So maybe I can have a little more information here. I can say, well, x is always less than 2, 1.9, 1.99. Then I subtract 2. Is my answer always positive or always negative? Use your calculator, plug in numbers, reason through it, whatever makes you happy. But I want to know. It's always going to be a little negative. Little negative. So I know that a non-zero constant over something that goes to zero is going to make the whole thing blow up. It's going to be an infinity. Because I have a positive number and a negative number, I can now be precise and say it's going to be negative infinity. Which, of course, some of you might say, but this was a couple of basic transformations. Of course, it's negative infinity. Well, the function can very easily be something I can't get with transformations. But you're right. If I can graph it, then why not? Sure. That's at 2. I'm coming towards it. My graph is going down. So it's nice to have that visual confirmation, but it's not always going to be possible. It's not always going to be possible. Does, I said limit equals, does that limit exist? Yes or no? See how nice I am? I ask only yes, no questions. It's 50-50 every time. Get a coin. Play along. 50-50. So even if you guess, you have a good chance of guessing right. I said limit of that function. I said an equal sign. Does the limit exist? Yes or no? The test question will very likely ask you, state if the following limits exist. You have to say every time it exists or it doesn't exist. Which one is it in this case? That is oh, good. Doesn't exist. Doesn't exist because infinity is not a number. It might get annoying that I say these things over and over and over, but I do it because every single test, especially the final exam, people do these things wrong all the time. And I don't want that to be you. So I am like a broken record saying the same things over and over and over so that in a test, you're going to sit there thinking, oh, wait, he said this like 15,000 times. I should remember. I'm doing it to help you because somewhere, someone keeps doing this wrong. Okay. Nice. That was a nice one. Simple, really. If you know how to look at this, super, super quick to do. And historically speaking, it's true. I'm not making things up. I wouldn't lie to you. Historically speaking, if you look at the final exams, the limit question page, which has a bunch of these on, maybe like 6 or so of them, where you have to do doesn't exist or exist and find it and so on, that is one of the worst scoring pages every single time. And I don't know why. I don't know why. It baffles me. I don't know. It's simply a lack of basic understanding because that's all we're doing for limits. It's just a basic understanding of this behavior question. There is very little that's tricky. Sure, if I see a square root, which is somewhere on this page or somewhere, if I see a square root, okay, slow down. Tricky things can happen. If I see an absolute value, all right, it's a piecewise function in disguise. Watch out, maybe two one-sided limits. Apart from those two things, it's a simple behavior question. It's just a matter of do I know how to approach this? Or maybe, oof, that was an ugly L. I'm totally guessing here at the reason why that is always the worst scoring page. Maybe people are expecting it to be something weird and difficult every single time. So then they overthink it. I don't know. I honestly don't know the answer to this. But every single final exam, I can put money on the fact that the limit question page will be a terribly bad scoring page. And I don't know why. I don't know. It's baffling when it shouldn't be. There's no reason why a question like this should be difficult. How do you approach something like this? Okay, fine, you could do the form. Sure. But I do quickly scan over the function. Like, oh, it's a rational function. I know if I'm not dividing by zero, I'm good. to just plug in the x value. But then I see, oh, I am dividing by 0 because x wants to be 2. So that's not going to be allowed. Go to the form, see what happens. Great. So I do scan over the function and see, oh, it's a linear function. It's a polynomial, defined everywhere. I could not care less what the x value is. I plug it in. 3 times 1 minus 4 equals negative 1 exists. So easy. If I know how to look at limits for our level, I will say for our level, there's really no reason that any of this should be super confusing. It's all a matter of, yes, there are a lot of little things maybe that I have to get used to. There aren't that many technicalities. There aren't that many combinations of how the form could look. I can get a slightly weird looking form I might not be super used to, but that's okay. There's more than enough problems. Any thoughts or questions so far? I'm just trying to scan through the problems here to see which one's a nice one that could potentially give me some problems. What is happening to the PDF here? I want to do 12 and 8 and be done with it. Then it is up to you. But I understand that the problem book doesn't have any solutions. Feel free to email me your attempts. Ask me to check it. It's all good. Just send me the questions with the answers. I don't want to jump around and go look, what was this question? Then go back to your email. Oh, that's super annoying. If all the information is in your question and you want me to check and answer, I am happy to do that. But it's ultimately up to you to practice, practice, practice. Number 12 first. 12 is limit of x approaching negative 5 from the right. 1 plus root 5 plus x. Close the square root. Put brackets around if you like. Do whatever you like. Okay. I see a square root. So I need to watch out if I'm at the endpoint, if I'm coming uh, towards the x value with positive numbers inside the square root so that I actually have something to evaluate, right? There are a couple of issues here. The issue is I need the function to be defined on the x values the limit wants to investigate. And because it's a square root, I need to watch out for the endpoint of the inside heading to 0, which is exactly what's happening. So form of the limit helps me just track the pieces. Now the one I can't do anything about, the square root I'm going to leave. So what's happening to 5 plus x? As x gets close to negative 5, that wants to get close to 0. But I'm always on the right of negative 5, which means I'm always a little bit more than that. So 4 point negative 4.99, negative 4.999. If I then add 5, I'm going to be positive, but very, very close to 0. So there's no issue with the positive aspect. The function is defined for any x value I want to investigate. However, I am at the endpoint of a square root, so I need to watch out. Is it a two-sided limit? No, it's a one-sided limit. I'm coming at it from the positive side. Everything is good to just plug in. And it's going to be 1 because the square root of 0 is 0. Exists. So yes, you don't show much. You show the answer, you say exist. And that's the same in the test as well. But you do whatever you need to do to figure it out. Okay. So these ones people find a little more confusing, perhaps. There are more things happening here, absolutely. We don't have time for number 8, but it's this very similar kind of thing. Very similar. Let me just do an example, another extra example here, very quick. If I ask for the limit as x approaches 5, I don't even care what the direction is, like that. What would we do now? I do the same thing initially in that I see a square root, so I need to watch out. Maybe you do want to check the form. Okay, 1 plus square root of something. What is happening to the inside something? Well, x gets close to 5. 5 plus 5 is 10. There's no issue whatsoever, right? It's only at the end point where the square root function has the issue at 0, and I'm far, far away from that. So I just plug in the x value. But if you're not sure you can plug in the x value, you can still look at the form, because in the case where the function is continuous, the form is the same as finding the y value. I can write a plus here. Actually, no, it's not a one-sided limit, right? So I can't even do a plus or a minus, but I'm far away from 0. It doesn't matter. It doesn't matter. So many people look at this limit and try and make it to be more complicated than it is. It's almost a trick question. It's almost a trick question that normally you would expect it to be a one-sided limit. You would expect the inside of the square root to be heading to 0. You expect the worst case. Then, when the question doesn't give you the worst case, you don't know what to do. Because you're sort of conditioning yourself to always expect square root of 0, worst case, endpoint, one-sided limits. Sometimes they just give you a trick question where there are no issues whatsoever. I'm not sure what your question is here. 5 plus -5 from the right. It's not a one-sided limit, right? So I can't say plus or minus here. But it's sort of my point that you expect something like this to have a plus or a minus, only one side. You expect inside the square root to be 0. So then many people just assume it's going to be 0. They don't actually read this for what it is. Not every question is the worst case. Some questions are actually tricking you in being just straightforward. Nothing to do there. So really read the limits carefully. Not many of these trick questions happen because they're trying to set you up, make you used to one thing and then flip it around and just be a normal continuous function at the x value in question. Lots of things to think about. Tomorrow we have a Q&A session. Use it. If you have questions, use the session. It's there for you. I don't mind sitting here doing nothing for an hour, but that's not really what it's there for. Use the time. And if you are confused and don't use the time to ask questions, well, that is entirely on you. Let me know if you have any questions. Otherwise, maybe I'll see you tomorrow. Maybe I won't. Until next time.